So as I said, that's the maximum point, which is over here. That's the minimum point. But let me say this: the maximum point, like if the maximum point is positive, right? The minimum point most of the time, I'm not saying all the time, most of the time will be negative, right? But I'll tell you what is important so far. So that's the maximum point. That is the minimum point. This maximum point over here is the one that we call it a crest. Okay. And then that
Yes.
minimum point over here is the one that we call it a trough. Right? So that is the crest, this is the crest, and that is the crest, right? And that is the trough. If we did have another part over here, that would be our trough. Okay, so basically we have two crests, right? And we have two trough. All right, let me just add something here. I want to show you something. Let me just add this one. Let me just add this one over here. Right. Now that is the crest, that is the trough. And the distance, and by the way, this is the time in seconds. Okay. Let me just zoom out for a little bit. That is the time in seconds, right? So this is the distance from the rest position. We call this a rest position, right? The rest position, that is
Yes.
where everything is zero. So here, that is where everything is zero. That is called the rest position. Okay. And then the distance from the rest position to the crest, we call it an amplitude. Yes, amplitude. And also the distance from the rest position to the trough, that is also the amplitude, right? So the amplitude, when we want to label the amplitude, is the distance from the rest position to the crest, and it's also the distance from the rest position to the trough. Okay? Do you have any question here? Do you have any question?
No questions.
Okay. Now, that's the first thing. Then the second thing is this. There is important now in terms of labeling. Okay. And the second thing is this. And then the distance between the crest and the crest is called it the wavelength. And the distance from the trough and the trough is also called the wavelength, right?
Yes.
And the distance it takes to complete one full cycle, right? Now the question is, how can you see one full cycle? You see one full cycle is made up of a crest and the trough, right? So one full cycle is made up of the crest and the trough. So here the one full cycle would be this. That is it. One completed cycle, right? And the second one,
yes,
is this one. Okay. Okay. Any question here?
no,
Right. So basically, we have two completed cycle here. We have two. Now, I want to show you something. The wavelength. Most of the people, they know that the wavelength is the distance between the crest and the crest, and the distance between the trough and the trough. And the last one, you can also identify the wavelength because the wavelength is also the distance it took to complete one full cycle. So it's the distance between here and here, right? That distance
yes,
is also the wavelength. So the wavelength is the distance between the crest. Okay, let me use the black pen. It's between the crest and the crest, and it's between the trough and the trough. Right? And it's also the distance it took to complete one full cycle. Do you have a question here?
no, sir.
Okay, that's the first thing. Now, in terms of labeling the transverse wave, I think from where if you label the transverse wave like this, you're done, right? Now we will go to the calculation
Yes.
part, right? So we'll go to the calculation part. Let's say we have the magnitude now. Let's say we have the time. Let's say here is here to there. Let's say is 0.1 second. Let's say here 0.2 second, 0.3 second, 0.4 second, right? Okay. So now in terms of the calculation, it's look like you are writing. Let me give you time to write and then tell me when you're done. So now we are done with the labeling part, right? So that's all that you need to know in order for you to label the transverse wave. Now let's go to the calculation part of the transverse wave. Now this transverse wave has got what we call the vibration, and then this vibration is coming in the form of a frequency. Okay, so in the form of a frequency, we call this a frequency is the one that is F, right? And the frequency is measured in the unit called hertz.
Hertz.
Right? And now, before I explain the frequency, okay, let me just start with the formula. The actual formula, there's two formulas to calculate the frequency, right? And I'll explain those formulas to you. The first one, in order for you to calculate the frequency is equal to 1 over T, right? Now, T is like if someone say explain this, that means that the frequency is the time is the rate of change in no, it's not the rate of change. I would say it is the time, the T is the time it take to complete one full cycle, because this is what we call the period. Okay, so the period it also can be, you can also make the T be the substitute of the formula, which would make the period being equal to 1 over F.
Frequency.
Right, which is 1 over frequency. Now the question is, how do I identify the period? Now let's go to here. What is the period of this wave?
The period.
What is the period of this wave? Now remember, I said the period, this is the time, it is the time taken to complete one full cycle. That is the period. Now what is the period of this wave?
2,3.
Is what?
0,2.
0,2. Good. 0,2.
Yes.
The period is the time it takes to complete one full cycle. So the one full cycle is this. So the period is here is 0.2. Now the people, they make a mistake and they think the period is 0,4. No, the period is not that. But now let me show you the trick. The trick, in order for you to calculate the frequency, you can find the frequency like this. You can say the frequency is 1 over T, or you can calculate the frequency. You can say the frequency is equal to the number
of full.
Yes, of completed or full of completed.
Completed
cycles
over
by total
1
time.
Total.
Right?
Total time.
Yes. So you can calculate the frequency like this, or you can calculate the frequency like that. Do you have any questions here?
No, not so.
Now let's just do some calculation now, right? Let's go ahead and do some calculation. Let's say we're given this wave, and then they say calculate the frequency for this wave. So we'll use the first method and we'll use the second method, right? So that you can see the difference. Now the first method, to calculate the frequency is equal to 1 over T. Okay, so the frequency, so here the frequency would be, because it's the period, so the frequency would be 1 over 0,2. So what is 1 divided by 0,2?
It's equal to 1. 5 hertz frequency. It's hertz.
Yes, so the frequency is 5 hertz. This is 5, right?
Yes.
Now that's the first method. Now the second method, let's say we are also using the same formula now. So when we are using this formula, that's how we are going to find the frequency. And then when we are using now, let's use this one, right? So if you are using this one, now the frequency is equal to the number, right? The number of completed
Yes.
cycle divided by the total time, right? So the number of completed cycle,
Yes.
you have to count how many cycles you have here. How many completed cycle we have here?
2.
2.
We
Now
have
the
2
total
complete.
time is that, right? Which is 0.4. So that would be 2 divided by 0.4. So what is 2 divided by 0.4?
2 divided 2 divided by 0.4.
Equal to 5 again, right? So
Yes.
that's what I'm trying to show you. So it's also equal to 5 hairs, right? That's what I'm showing you, that you can use this one or you can use that one. Do you have any question here?
Yeah. What did they say if there were 3 completed cycle? Would you use the last one to calculate what's taken?
If you have 3 completed cycles,
Yes.
no, it doesn't matter. Doesn't matter. You can use the first one or you can use the second one, because for the first one we need to just find the period. And then the period, just look at what is the period of the first wave of the first completed cycle. Then once you got the period, you can say 1 divided by that time to complete that full cycle. You get the same frequency. Or if you're using the second one, yes, you will take if you have 3 completed cycles, say 3 divided by the total time to complete those 3 cycles. You also get the same thing. But I would suggest that you use the first one, right? Use the first one if you can.
Yeah.
If you have the time, even to complete 1 cycle, use that. Use that. Okay. But
Yes.
if you have if they gave you the number of completed cycle and they gave you the total time, they gave you like the time. They didn't give you the time here and there, but they gave you this one, right? You can use this one because you can able to detect how many completed cycle you have, and you can also detect what is the total time you have. All right? Do you understand?
Yes, sir.
Yes. Any other question?
Yes, sir. You continue.
Right. Now, the last calculation that you need to have, because when you're dealing with transverse wave, right, the wave is moving, right? So we also need to calculate the speed for the wave. Okay. Now the unit, let's start here. The unit for the frequency is hertz, right? But another unit for the frequency,
Yes.
because if you notice here, what we are actually doing with the frequency is equal to 1 over t. So we are actually dividing the time time that is measured in seconds. So the unit for frequency is also is also per second, right? Now, now
Yes.
the wavelength, actually we are talking about the distance, right? So the wavelength is in meters. The unit for wavelength is meters. So the speed would be equal to the frequency times the wavelength.
Rounds.
So this is the
Yes.
velocity. So the velocity is the frequency times the wavelength, because what we are actually doing, we are multiplying the frequency, which is 1 over seconds, times the wavelength, which is in meters. So if you are multiplying this, we'll get the speed in meters per second, right?
Yes.
Any question here?
No, sir.
Let's say we are given that the wavelength here is 2 meters. I'm making an example. Let's say that we're given here that the wavelength is 2 meters. Now, if that is given, now we already got the frequency, so we can calculate the speed for this wave. Okay, so now the speed would be v equal to frequency times lambda. All right, so the frequency is 5 hertz times the wavelength, which is 2
Multiply
meters.
2 is equal to 10
Yes, equal to 10 meters per second. So
meters
that
per
is,
second.
yes, so that is the speed for the wavelength for the wave. And the question here?
Yes. Wasn't you supposed to put -1 there by meters per second?
Where?
They by
Here.
no, yeah, meter per second.
Oh, yes, you can. Okay, let me show you this. If I'm saying 10, if I'm saying, if I'm like the unit, if my unit is meters per second, right? I can do it this
Yes,
way,
sir.
right? I can do it this way, or I can put it this way. I can say 10 meters per second. You understand? This or
Yes, sir.
this or means this. It's up to you. If you want to write it this way, write it this way. If you want to write it this way, that's fine. right?
Okay.
Do you have any question? Do you have any other question?
Yeah.
All right.
No, sir.
Uh,
We continue.
all right. So the last thing, right, I want to explain to you when it comes to transverse wave is how to find the amplitude, because in some cases they can trick you, right? You can have the transverse wave like this, right? You can have a transverse wave like this, and then they ask you, and then they say, and then they say from the distance from here to there is maybe 3 meters, and here to there is -1. And then they say, what is the amplitude for this? Calculate the amplitude. Now you can see that it's not easy to find the amplitude here, right? Because
Yes.
if you have the same like most of the time, if you have the amplitude, the maximum point and the minimum point, they have the same value but the opposite direction. That is can be easy, because let's say we have +2 on top and then we have -2. That would be easy. That the amplitude is 2. But if you have something like this, that is quite complicated. But now I have the formula that will always make you to be safe in order for you to calculate the amplitude. So the formula, the amplitude is equal to the lowest point, right? Um, no, is the highest, is the maximum point or the highest point minus the lowest or the minimum divided by 2. So the highest point is this point over here, which is 3, and the lowest is this one. Note that we are subtracting. Yes, a question?
Uh, can you start over again?
Okay. So I'm saying, um, let's say we have something like this, okay? Let's say we have something like
Yes.
this. We have a, do you see this, right? Now, if you have
Yes.
something like this, let's say they will say, calculate the amplitude, or what is the amplitude when we're having something like this? Because you know that normally, if we have a wave that is at the rest position like this, okay, we can easily find that the amplitude is 2 here. Maybe the amplitude here is -2, right? But here you can see that that is the trick, because the maximum point is 3, while the minimum point is -1. Right now, it's not easy for you to detect what is the amplitude, but if you are using this formula, you can detect, you can able to calculate the amplitude, because they can ask you what is the amplitude for this wave. Okay, now in order for you to calculate the amplitude, you need to say the highest point or the maximum point, which is this point over here, right? This one, minus, right, the
The
lowest
lower.
point, which is that point over there, divided by 2. Any question?
No. No, sir.
So that means we will have 3 minus,
Minus
okay,
1
into minus, be careful,
bracket.
1
Yes.
divided by 2. So what is negative times negative?
Positive.
Positive 1 divided by 2. It should be 4 divided by 2, which should be 2. So your amplitude should
2.
be 2, right?
But what's the units for amplitude?
Oh yes, amplitude meters. That if it's in meters, if it's inside centimeters, you write centimeters here. You ask me that, right?
Yes.
Okay. Any other question?
No, sir.
Right. I have a question for. I have